All right. And this will also appear in your finals. Okay, again, the diagram will be the same. The conditions of the problem will change slightly. Okay, here it's really important that you write down what is required and that you make a, look at this, you have to make a free body diagram for each object. Okay, so this is object, or yeah, object 1 and object 2, right? So we can put the free body diagram here or there. Let's put it here. Okay, now let's put it here. Okay, so for object number 1, let's start with object number 2. It's easier. So let's look. Here in the center of gravity is where the point of equilibrium happens. What is going down is FG1. What is going up? FT. Okay, there's a tension here in this force, in this cord, because it's supporting this weight. And that's your first free body diagram. Okay, and you are given only the mass, right? You're given the mass 1, which is 150, take note, kilograms. Okay, so in the basis, what is required? FT in newtons. What else is required? FF in newtons. What else is required? Acceleration in meters per second squared. And the last thing is the time to move, time in seconds to move, h equals 5 meters. Okay, so we're going to do this little by little. So the first basis is that Fg is equal to m times g, mass times the gravity. Okay, so solution here, right? A. Fg1 is equal to m1 times g. m1 is 150 kilograms times 9.8 meters per second squared. So Fg1, okay, this is not a requirement, but you have to solve it first. 150 times 9.8 equals. Okay, so newtons. Okay, don't put a box because it's okay. And look, from this here, the summation of forces along the y is equal to 0. What do we have? Ft is equal to Fg1. Okay, Ft is equal to this one, 147 newtons. Okay, and so we have A. Check. Okay, so moving along. How do we get the frictional force? Well, we have to make a new body diagram from here, right? So this is object number 2, object number 1. Okay, what is going down is Fg2. It's Fg2 because this is a different weight, or this is a different mass. Okay, and countering that is normal force. Okay, and then pulling here is Ft, and retarding that is Ff, right? Because it is moving in this, it will move in that direction when it starts to move. Okay, so the frictional force is going the opposite. Hopefully that's clear. I didn't write it here because I thought it would be more confusing. So hopefully this is clear, right? And you look, since the forces are against each other, That's the way it's laid out. Okay, let's look for what's next is the normal force. This is not going to go, this is not going to fly, it's not going to sink. So the summation of the forces along the y here is 0. And what is that? Fn is equal to Fg2, which is what? M2 times G. Okay, and what is F2? F2 is 200 kilograms times 9.8 meters per second squared. Okay, so right away we have Fn. And using our calculator again, 200 times 9.8, 1,960 newtons. Okay, check. That's the second one. Okay. Oh, sorry. Nope, that's not what we're looking for. We're looking for the frictional force. So we have to have another basis. The frictional force is equal to mu times Fn, which we've just solved. Okay? And so what is that? Ff is equal to, and what is the coefficient of friction is given. Okay, I have to move this up so you can see it. 0.20 times 1960 newtons. Okay? So times 0.2. Ff is equal to 300 newtons. Okay? See? That's why you have to write the required. Otherwise, I would have stopped here, which is wrong. I'm only looking for the frictional force. Okay, how about the acceleration? Ooh, difficult. Okay, here, this is along the x. And it is not equal to 0. You look at this. This is going to fall. That's going to pull it. So this whole thing will be moving. And therefore, the summation of the forces along the x will be equal to ma. It will move, right? This a is to be determined. Okay? And what are the summation of the forces? Let's look here along the x. Which one is greater? This is greater than that. So Ft minus Ff is equal to ma. All right? A, which is what we're looking for, is Ft minus Ff divided by m. Okay, let's solve for A. We have Ft there, 4,700 newtons. Okay, look at this. Because of the pulley, the tension here will be equal to the tension there. Always. Frictionless pulley, that's what it does. It transfers the tension along a cord. Okay, minus the frictional force, 392 newtons. Divided by, here's the tricky part. What is the mass? Look at this. What is moving? They're both moving. So they will both affect the acceleration, right? They will move as one body. And so what is it? 200 plus 200 kilograms plus 150 kilograms. Okay? And what is that? Now you can just compute. 70 plus 392 equals, divided by 350. Oh, that's not it. Okay, one more time. 1470 minus 392 equals, divided by 350. Okay? 3.08 meters per second squared. Okay, that's the A, and you have to do this twice because that was really complicated. So 70 minus 342, 392 equals, divided by, this is 350. Okay, so that's correct. Okay, I verified it, which is really good that you do that. In a complicated problem like this, you have to. Okay, so, and the basis for that is the summation of forces is equal to ma when it is not moving. So there is motion. When it's moving, so there is motion, right? Because it's unbalanced. And then for the last part, we're going to look for the time and the distance. So h is equal to VOT plus 1/2 AT squared. Okay? It starts at rest, so solving for t, what is it? T is equal to the square root of, look, you multiply 2h divided by a, right? And people were asking me, why do we need to do this? Well, if you have to grow in your calculations style, or you have to be able to do this, solve for the variable that you're looking for, and you're looking for t. There, it's very simple. You have h is given, you solve for this, so this is a very simple thing. You can write it anywhere you like. T is equal to the square root of 2h over a. Okay, 2 times 5 divided by 3.0. Okay, notice that I'm keeping with the significant figures because I'm calculating these things and I don't want to get too far away. Okay, when you get to time though, just the number of seconds or one decimal place is fine. Okay, so again, let's see. 10 divided by 3.08, and then you take the square root, and you end up with t is equal to 1.8 seconds. Okay, and that seems correct. Okay, check. And good, I stayed inside the okay. Good luck.